discuss exercise 2.7 from mathematics of class 9 and 10, and from examination point of view this is a very important exercise. So let us start with question number 1. That is 8 raised to the power 1 over 3 into 36 1 over 2. 8 can be written as 2 raised to the power 3 whole raised to the power 1 over 3 into 36 can be written as 6 squared whole raised to the power 1 over 2. Powers get cancelled, 3 gets cancelled with 3 and 2 with 2, so we are remained with 2 into 6, and that is equals to 12, and that is our answer. So let's move to question number 2. That is 64 raised to the power minus 1 over 6. This question can be solved in the multiple fashions. So let's do it with one method. That is 64 can be written as 2 raised to the power 6, and again you can see that 6 cancels with 6 and we are remained with 2 raised to the power minus 1. So the answer is 1 over 2. Always remember that if we have an expression like a raised to the power minus m, it is always equals to 1 over a raised to the power m. So it's a common relationship, and always keep that in mind. Question number 3, that is 256 over x squared whole raised to the power 1 over 2. So 256 can be written as 16 squared over x squared as it is, whole raised to the power 1 over 2. So 16 square over x squared can be combined, can be written as 16 over x whole raised to the power 2, and that is again whole raised to the power 1 over 2. The powers get cancelled, 2 with 2, 2 with 1 over 2, or 2 get cancelled with 2. So we are left with 16 by x, and that is our answer. So let's move with question number 4. There is 81 x raised to the power minus 8 z4 whole raised to the power minus whole raised to the power 1 over 4. Just rearrange this question as 81 z4, put x minus 8 in the denominator, whole raised to the power 1 over 4. So again we can write 81 as 3 raised to the power 4, z4 as it is, and x8 can be written as x square whole raised to the power 4. So 3 raised to the power 4 z4 x squared can be written with the common power, that is 4. So we write 3z over x squared whole raised to the power 4, and that is whole raised to the power 1 over 4. So the powers 4 and 1 over 4 get cancelled, so we are remained with 3z over x squared, and that is our answer. Let's start with question number 5. That is 27 whole raised to the power 22 n by 3 into 8 raised to the power minus n by 3 whole over 18 raised to the power minus n by 2. Just rearrange this question just like this. 27 whole raised to the power 2n by 3, 18 comes up. In order to make its power positive, 18 is coming up, so we write 18 raised to the power n by 2, its power now becomes positive n by 2, and 8 comes down in order to make its power positive, so whole upon 8 raised to the power n by 3. Again 27 can be written as 3 raised to the power 3 or 3 cubed whole raised to the power 2n by 3 into 18 can be written as 2 into 3 squared whole raised to the power n by 2 whole over 8 can be written as 2 cubed whole over n by 3. So we are cancelling something. There is 3 with 3 in 3 cubed gets cancelled with 2n by 3 is 3 into we get 2 into 3 squared whole. It is a whole power of n by 2, so we just have power of n by 2 on each and every element. That is 2 raised to the power n by 2 into 3 square raised to the power n by 2 whole over the 2 cubed gets cancelled. The cube of the 2 cube gets cancelled with the n by 3, so we get 2 raised to the power n in the denominator. So we have now 3 raised to the power 2n into 3 and into 2 raised to the power n by 2 into 3 squares. 2 gets cancelled with n by 2, so we are remained with 3 raised to the power n, and again 2 raised to the power n is our term in the denominator. So what we are left with now? We have 3 raised to the power 2n into 2 raised to the power n by 2 into 3 raised to the power n whole over 2 or 2 to the power n. So now simplify 3 with 3 and 2 with 2, we get what? 3 raised to the power 2n into 3 raised to the power n, they have the same basis, so their powers are getting added together. So we get 3 raised to the power 2n plus n whole over, we bring n by 2, 2 raised to the power n by 2 below in the denominator where the power is greater. So we get 2 raised to the power n minus n by 2. So we get the answer as 3 raised to the power 3n over n minus n by 2. We get 2 raised to the power n by 2. So let's move to question number 6. That is AP over AQ whole raised to the power minus Q minus P multiplied by AQ over AR whole raised to the power minus R minus Q multiplied by AR over AP whole raised to the power minus P minus R. So this can also be written as AQ over AP. We just shuffle numerator with the denominator in order to make the powers or the indices positive. So we write AQ over AP whole raised to the power Q plus P. Similarly, AR over AQ gets R plus Q, and AP over AR gives us P plus R, all positive powers now. So if we can write it like this, it would be AQ over AP can be written as A raised to the power Q minus P whole raised to the power Q plus P multiplied by AR over AQ can be written as A raised to the power R minus Q whole raised to the power R plus Q multiplied by AP over AR can be written as A raised to the power P minus R whole raised to the power P plus R, and there is a power on the power, so the powers get multiplied. So we get this to be equal to A raised to the power Q minus P into Q plus P, both powers get multiplied, into A raised to the power R minus Q, R plus Q, and similarly A raised to the power P minus R and P plus R. As we all know that there is a formula, very famous formula, that there are two expressions A plus B into A minus B that gives us A squared minus B squared. So Q minus P and Q plus P when get multiplied will give us A raised to the power Q square minus P square into, similarly R minus Q, R plus Q will give us A raised to the power R square minus Q squared into A raised to the power P squared minus R squared. So the bases are the same and the powers get added. So we get A raised to the power Q squared minus P squared plus R squared minus Q squared plus P squared minus R squared. So all the powers are getting cancelled out by each other. So the answer is A raised to the power 0, and that is always equals to 1. So this is all from exercise 2.7 from question number 1 to question number 7. So in the next video we will be covering the remaining questions from this exercise, and if you have still not subscribed our channel, that is online training YouTube channel, so I would request you to subscribe to this channel and press the bell icon in order to get the latest notifications from this channel and get the latest updates about the new videos. Thank you very much. Ciao.